This is how a nerve impulse works normally. There is an uneven distribution of negative and positive charges inside and outside the neuron cell. This is referred to as polarity. Sodium channels open and close to allow positively charged sodium ions into the cell. The movement of the sodium ions is what creates the nerve impulse. Neurons are not physically connected to each other. The space between neurons is called the synaptic cleft. When the impulse reaches the end of the neuron, vesicles are triggered to release the neurotransmitter acetylcholine, or ACH, into the cleft between the two cells. ACH binds to acetylcholine receptors on the sodium channels of the adjacent cell. This triggers the opening of the sodium channels. Sodium ions then enter the adjacent cell, depolarizing the membrane. This triggers a new impulse in the adjacent cell. The ACH detaches and is broken down by the acetylcholine esterase enzymes, or ACHE. There are currently 4 main insecticide classes available for public health use: carbamates, organophosphates, pyrethroids and organochlorines. Pyrethroids and organochlorines are sodium channel modulators. Carbamates and organophosphates are acetylcholine esterase inhibitors. Let's first look at the sodium channel modulators. These insecticides keep the sodium channels open. This leads to a continual flow of sodium ions into the neuron and disrupts the normal balance of electrical charges within the neuron. With no polarity changes, all impulses cease, which results in paralysis. Now let's look at the acetylcholine esterase inhibitors. These insecticides bind to ACHE. This prevents the breakdown of ACH. When ACH is not broken down, it continually triggers the reopening of the sodium channels. This allows constant flow of sodium ions into the cell, disrupting normal impulse transmission. This ultimately kills the vector.